Hello everyone, November 21st. Alright, let's do this. Flip columns and a maximum what? Flip columns for maximum number of equal rows. M by n binary matrix, you can choose any number of columns in the matrix and then flip every cell in that column. Return the maximum number of rows that have all values equal after some number of flips. The max number of rows that have all values equal after some number of flips. So you do some flips, and after you flip, we want to know the maximum number of rows that have that have the same value. So we don't really care about the number of flips. What we care about is the final result. So the first one is a 2 by 2, have a 0, 1, and 1, 1. So we flip. Oh, we can only flip columns. We can only flip columns. We can only flip columns. And we want to know any number of columns. I want to flip 0 turn into 1, and we want the equal rows. Second example, again, it's 2 by 2, 0, 1, and 1, 0. So you say you flip this, so it turn into 0 and 1. So you have 2. Third example, zero, 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 0, 0, 1, and then 1, 1, 0. Okay, so I flip. Let's say flip this, become 1, 0, 1. So you have 2. I think that's it. You can flip this. Yeah, it's the same thing. We don't really care about how many numbers you flip. What we care about is the result. We want maximum number of rows. So when you flip, right, you want to make it equal. You can always make something equal, right? If a row, and you have to realize if we have rows that already are equal, and if you flip any column, that will be broken, right? That will be broken. So if you have rows already filled, and let's say you have, more than half, right? If you have more than half, then no matter how you flip, the maximum you can get is, because half, if every time you flip once, then half of them, more than half of them would not be, right? Would not be good. And if you flip all of them, that's essentially the same. So if you have more than half, or even half actually, because if you have half are already the same, that's the answer. Because you're not going to make it better than half, right? You cannot make it better than half. But otherwise, if you don't have half, then there is a chance. Because once you start flipping, the ones that's already good, this is no longer be good, right? So you need to find more among all the other rows. And for those rows, again, the ideal is you can always, because every time you flip, right? Every time you flip, it's on a column. So right, all the 0 become 1, all the 1 becomes 0. So for each row, right, there are some places, right, that need to be flipped. So for one, you can say, for a row, you can say I will count it as a 1. So we find out which positions need to flip, right? And okay, so for each row, I find out if it's a 1, which position needs to be flipped and which position does not have to be flipped. Or if it's a 0, we can do the same thing, which need to be flipped, which does not need to be flipped. And this is its pattern, right? This is its pattern. Then we go through the whole thing and see how many times the patterns match. How do you match patterns? We can use string, right? We can use string, and yeah, like if it's a, so basically what I say is, in this to match, so we have a keep, so this one is a 1, this will be flip, or keep. So this can be k. We can say keep, right? Or flip. Yeah. So this I can say the first row is going to be a f flip or keep. This one, if we want to keep 0, that can be, oh, yeah, so this is if I want to be 1, this is if I want 0. Right, so if it will be 1, this will be flip, keep. This will be keep, flip. That's just a reverse of this, right? And if it be 1, will be keep, flip, keep. So essentially, I don't even need this. I just say, if I want everything be 1, what's the pattern going to be, right? What the pattern is going to be. And once I find that, I need to match. You know what? We do need, right? So we can say 300. So we have FFF, like we count 1, and from FFF I can get to KKK, right? And then, yeah, so if we just go through one, we'll have FFK, right? Just like, okay, FFF, so we count, that's a 1. Right? KKK, that's a 1. And then FFK, that's a 1. KKF, that's a 1. KKF, that's a 2. FFK, that's a 2. Right? Yeah, the thing is you do have to go both. And then eventually you just find the pattern with the most pattern. That should be the answer. Okay? So give this a shot. Whoosh. Ooh. Ooh. Are we having the same problem again? Cannot copy and paste? No, we can't. Alright, so basically I need a map of, call it string and integer. I wonder if there is a better way than the string. We can call patterns. Okay. And now we just go row by row. So for int of matrix string builder string builder 1 pat 1 string builder pat 2. Okay. For int of row if e is equal to 1, right? Oh, it should be pattern 0 and pattern 1. So if e is equal to 1, then pat 0 dot append. So 1, so that's a flip. Right, and then pat 1 dot append, that's keep. Else pat 0 dot append, keep, pat 1 dot append, flip. Okay, once we're done, we have patterns dot put patterns, not patterns, pat 0 dot toString, pat 0 str, pat 0 dot toString, pat 1 str, pat 1 dot toString. Then we're gonna say pat 0 str patterns dot get or default pat 0 str. It will be 0 plus 1. Okay. Okay, and then this should be pat 1. Right, pat 1 cannot be resolved. Okay, so once that's done, I can also have, int rest equal to 0, right? And then for each row, once we're done, yeah, I still think, like, is it really necessary to go both? Well, I think it will be easier to go both, but when we check, I think we're going to check it once. think one of them is enough. One of them is enough. Why you need both? Well, both because they need to match. Right? So, yeah, I think we do need both. And this, we need this. But once we get it, because the 0 pattern is essentially the same. Right? Essentially the same. Alright, let's see. Alright, so the runtime for this. Alright, I'm not even sure if it's correct, but it looks solid to me. For each row, find the pattern of keep or flip. Right? The two rows, the rows with the same pattern can become equal rows after flips. And thus the question becomes finding the max count of the same keep or flip pattern. Alright, so definitely OMN, because I have to go through this. Right, OM times M times N, because I go through. Oh, I think that's about it. OMN. Of course, you also can say something about the stream building. Let's see if this one works. It does. Does work. Okay. That's good because I really don't want to spend too much time today. Brute force and squared hash map. Yep. Oh, hold a second. Hold a second. What is this? This is a true and false. Okay, they talk about pattern. Finding a pattern that shows up the most often, yeah. Convert it into its pattern string. Okay, let's see. Oh, I see. They use TNF. They have a pattern string. They have a frequency. That's the same. Pattern builder. So current 0 is equal to current row column. What the hell is column? Oh, I use the start. So basically, say everything is trying to fit into the start. Yep, I think that's better than mine. let's copy and paste. Okay, so okay, this is from the official solution, which has the same idea but slightly better implementation, as it does not require two patterns to be built. We only need to build one, right? We only need to build one, which is to always keep the row the same as the first element of the row. Oh. Keep. What I was thinking about, maybe I can do, I think this one's easier. So I can say path.append row I is, oh shoot, what the hell are you doing, man? Row I equal to row 0. If it's equal, keep, otherwise flip. Oh, so much shorter. Yep, much faster, right? So you only need to build one. That's why it's faster.